My name is Nur Aina Binti Johari, TA190111. So I will explain the 3.1 part. Okay, so the VA we put as 3, constant value is 3, the KB is 2, the pulse generator, the amplitude is 1, and the pulse width is 40% of period still the same, and the phase delay is 3 seconds. So for the feedback control, we add the transfer function here and connect with the scope and the plus minus here, and then we put the transfer function as 1 over s, and we run the plot diagram. So we double click the scope. So this is the final results for the 3.1.
Assalamualaikum and hi, my name is Huzaima Rabia binti Muhammad Karim Nizar. My metric number is TE19015. I will continue to explain about the feedback control system. We can see the graph here, and the rise time is 2.861 seconds, and the overshoot is 121.667%. So the advantage of a feedback control system: using feedback in closed loop systems will improve control by automatically adjusting the controller output to reduce the error. This helps reduce the effects of dynamic disturbance. Feedback also adds stability to an unstable process, ensuring a repeatable and reliable control loop.
Hi and Assalamualaikum. My name is Nora Shikin binti Nasaruddin. My matrix number is DA190039. I will explain the question 3.3. Tabulate and study the effect of the CS with K equal to 0, 5, 10 and 15. This is the block diagram of feedback control, and we need to change this K with the value of 0, 5, 10 and 15. First, we need to change to 0. And we click run. And this is the output graph for K equal to 0, and the rise time is 93.742 millisecond, overshoot 18.493%, and settling time is none. And we change again to 5. And this is the output graph for K equal to 5, and the rise time is none. The overshoot also none, and settling time is also none. For K equal to 10, this is the output graph for K equal to 10. The rise time is 0, overshoot infinity, settling time is none. For K equal to 15, and this is the output graph for K equal to 15. The rise time is 0.00 second, overshoot infinity, settling time is none. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurisha binti Shukri. My metric number is TE190115. So today I'm going to discuss and compare the results obtained using the two methods, that is for feed forward and feedback. So for feed forward control, it necessitates just a fundamental understanding of the process to be regulated, as a mathematical model of the process is not necessary. However, it is highly valuable for control system design. However, in order to employ feed-forward control effectively, at least an approximate process model must be known. Both of the feed-forward and feedback control studies were conducted successfully. So, by the results and the signal of both transfer function, it shows that the feedback control system rejects load disturbance better than the feed-forward control design.
Assalamualaikum and hi, my name is Nur Akila binti Saidan. My metric number is DE190044. So today I will talk about conclusion for the main finding, which is the major observation that was discovered based on the instruction and the exercise throughout this experiment is for the speed control system. We did the two type of system in this experiment, which is feed forward and feedback. So the load or the major disturbance is measured in a feed forward system, and the manipulated variable is updated to minimize deviation from the set point in the control variable. So there are two kinds of feedback, which is negative and positive. The set point and output values are multiple together for positive, while the set point and output values are subtracted for negative. The negative feedback system are more stable than positive feedback system, and they are also more resistant to random fluctuation in component values and inputs, which is every component value change have an effect on the output graph, which is the component of VA, TD and KB, the feed forward generator and feed forward gain KFF and feed forward control all had an effect on the output graph in this experiment. So by referring to the BI level measurement in the scope component, we can examine changes in the rising time value, maximum, overshoot and settling time for both systems. For the recommendation for future experiment, we can know the value of TD, VA and gain must be set appropriately by testing the input values for each component as much as possible to ensure that the feed forward and feedback output satisfy the theory, so that the block diagram must be designed to follow the correct arrangement and connection for the component that will be used to measure the characteristic of the speed control system. And before we running the simulation or creating the block diagram, we have to know the function of each component that will be involved and must be studied beforehand to avoid mistakes during the setup, such as the component for act like feed forward gain KFF and feedback control. That's all from me.